Let's talk about some area problems. Remember, we're going to use guess, givens, where you just write everything you know from the problem, including a diagram. The unknown, what are you looking for? What are you asking for? I'm going to put any equations you know you're going to need right here. This will just help you at the end. Equations, identify your primary and your secondary equation. Your primary equation is going to be related to what you are maximizing or minimizing. All right, this is what you're going to take the derivative of, and you need to get it into one variable. So to solve, you manipulate the secondary equation and plug it into the primary equation and the solution. Find the derivative, find the max or min, and then make sure you check to see if you have a max or min. So let's try this problem. A rectangular page is to contain 24 square inches of print. So here's my 24 square inches of print. And I'm going to put on here A is 24. And I'm going to use your book's notation. X, Y, here is my marker here. So I know X times Y is 24, and I'll put that down in just a second. I know A is 24. All right. The top and bottom margins are 1.5 inch. All right, so this is 1.5 inches. And remember, I called this X. So I'm going to be able to pull an equation out here that 1.5 plus X plus 1.5 is the length of this side right here. So X plus 3 is the length of this side. Well, this side right here is 1 plus Y plus 1, or 2 plus Y. That's a Y. All right? So you see what I've done on my diagram. I've quite literally created my problem. Now, what is my unknown? What am I looking for? I'm looking for the dimensions of the page. So I'm looking for X plus 3 and 2 plus Y. Or you could just write dimensions of page. Now, what equations do we have? We've kind of already done them over here. I know X times Y is 24. And this is my secondary equation. A lot of times it's easier to find the secondary equation first. But we want the dimensions of the page. So this is what we're going to need to maximize or minimize. So we can use, in this case, the least amount of paper. So what do I have here? The area of the paper is X plus 3 times Y plus 2. All right, now I'm going to put a little star here because this is what I want to minimize. I'm going to need to take the derivative. The next step is solve, and some of this kind of gets blurred in here. I'm going to solve the secondary equation here. So Y is 24 over X. I could have solved it for X. That was fine. And now I'm going to plug this into my primary equation. So the area is X plus 3 times 24 over X plus 2. Now at this point in time, we're going to do dx. However, I'm going to multiply this out. You're going to find, if you do, it makes the chance of error less. Okay, the next step, let's do our next solution. I need to do d80. X is 2 minus 72, got carried away there, over X squared. I want to set this equal to 0. Now this is true when X is plus or minus 6. Because I have a real piece of paper, I know I have to have X is 6 inches. I'm not done. Now I need to show, do I have a max or a min? So if X is less than 6, then if X is less than 6, then d80X is less than 6. This is going to be a larger number, so this is going to be negative. And if X is greater than 6, d80X, this will be a larger number, so this will be smaller, so this will be positive. So I'm going to have the slopes going from negative to positive. So I have a minimum. So I just showed that I have a min. Am I done? Of course not. We have a lot to go through with this problem. I know y is 24 divided by 6, which is 4. And now let's go back up and check. I think I'm done, right? No. This is a value of writing down what you're looking for. I want the dimensions of the page. So I need x plus 3 and y plus 2. So x plus 3 is 6 plus 3, or 9. And y plus 2 is 4 plus 2, or 6. So the dimensions of the page are 9 inches by 6 inches. Now I'm done.